Hello, and welcome to this session on foundational components of Microsoft Azure Stack. This is the module on Azure Stack Identity. I've created an Azure Stack shortcut for you where you can find a lot of this content more in depth online at aka.ms/azurestack/identity. My name is Mark Grimes, and I'll be presenting this content to you. What we'll cover in the next hour or so are basics about identity terminology in the background, the Azure Identity Model, which is applicable to Azure Stack, Azure Stack Identity Fundamentals, a little bit of information about directory-based authentication, and the different types of tenant topologies supported by Azure Active Directory as well as ADFS, and then finally a little bit more information about Active Directory Federation services and how they work with Azure Stack. Directory tenants. This is common for all of Azure and Azure Stack. Azure supports multiple Azure Active Directory tenants. Each directory tenant is segregated from one another. And within Azure, you can do synchronization from a tenant via Azure AD Connect. ADFS is treated as a single tenant in an Azure Stack disconnected scenario, and in that scenario, it only supports a single organization with one Active Directory. In the cloud-enabled workplace, a tenant can be defined as a client or an organization that owns and manages a specific instance of that cloud service. With the identity platform provided by Microsoft Azure, a tenant is simply a dedicated instance of Azure Active Directory that your organization receives and owns when it signs up for a cloud service like Azure, Intune, or Office 365. Each Azure Active Directory tenant is distinct and separate from other Azure Active Directory directories, just like a corporate office building is a secure asset specific only to your organization. An Azure Active Directory tenant was also designed to be a secure asset for use by only your organization. The Azure Active Directory architecture isolates customer data and identity information from commingling. This means that users and administrators of one Azure Active Directory tenant cannot accidentally or maliciously access data in another directory. Users. After deploying Azure Stack, you'll need a tenant user account so you can explore the tenant portal and test your offers and plans. You can create a tenant account using the Azure portal or by using PowerShell. This happens by actually logging into the Azure portal to create the user account to be used if you are implementing Azure Active Directory as your identity source. Users are always created in the context of a directory. The directory that the user is first created in is called the user's home directory or home tenant. Azure AD has functionalities where users can be invited across tenants. When this happens, none of the properties of the user go over to the other tenant. The credentials and assets of the user still stays in the home directory tenant. This user in the second directory, known as the guest user on the right side of the picture, is also known as a foreign security principal. And that directory is called its guest directory tenant. If the Azure Stack deployment has been deployed with Active Directory Federation services or ADFS, then the user accounts can be created on the proof of concept machine or the production machine from Active Directory users and computers, also known as the shortcut dsa.msc. Applications. An application is registered in the context of a directory as well. An application can be single-tenanted or multi-tenanted, which means users from other directories can authenticate against this app. The concept of home and guest is applicable to applications in the same way it is to users. Businesses have two basic requirements for all applications: to increase productivity applications should be easy to discover and access. To enable security and governance, the organization needs control and oversight on who can and actually is accessing each application. With Azure Active Directory, all applications you publish for your partners and or customers, and those customers can be with your business or a consumer in the case of a cloud solution provider or CSP, they have the same identities and access management capabilities. This enables you to significantly reduce your operational costs. By providing central access management and single sign-on for all your applications, Azure Active Directory provides the solution to the main data, security, and production problems. Service principals. So this is the third concept. We started with users, then applications, then service principals. A service principal is an instance of an application. When you go into the Azure Stack portal or Azure portal and register an application, two objects get created. First, the application itself, and then second, the service principal. This has a similar relationship to an object class relationship in programming. A service principal has a set of credentials. The app ID and the key that effectively creates the service principal. Therefore, it is an instance of an application which may or may not have credentials with it. When you have a multi-tenanted application, it does not create a second instance of the application, but a second service principal in the other tenant, as shown on the right side of the picture. When an application needs access to deploy or configure resources through the Azure Resource Manager or ARM layer in Azure Stack, you will create a service principal, which is an identity for your application. You can then delegate only the necessary permissions to that service principal. When someone has been invited to a second directory tenant, you must consent to them coming into the directory tenant. When an application tries to log you in, it will show a consent screen, as shown on the right side of the diagram here. This app wants these permissions for this application. Are you willing to give it or not? In Azure Stack, admin consent is set up to have admin consent because we want the proper relationships set up between organizations. This way, users can all start to use Azure Stack. Every app that uses the v2.0 endpoint will need to be registered at apps.dev.microsoft.com before it can interact using OAuth or OpenID Connect. The app registration process will collect and assign a few values to your app: an application ID that uniquely identifies your app, a redirect URI or package identifier that can be used to direct responses back to your app, and a few other specific scenario values. Many of the tokens issued by the v2.0 endpoint are implemented as JSON Web Tokens or JOTs. A JOT is a compact URL safe way to transfer information between the two parties. The information in a JOT is called a claim, just like in SAML. It's an assertion of information about the bearer and subject of the token. The claims in a JOT are JavaScript object notation or JSON objects that are encoded and serialized for transmission. Because the JOTs issued by the v2.0 endpoint are signed but not encrypted, you can easily inspect the contents of a JOT for debugging purposes. I'm not going to spend a lot of time on this slide, but this is just a little bit more in depth about different types of protocol support. I actually have a shortcut. It's pretty easy to remember, aka.ms/azure/protocols. So this talks about the various types of protocols we have supported. Just real quickly, we have OAuth 2.0, which authorizes access to web applications. We have OpenID Connect, which is a simple identity layer. And you notice from the asterisk to that, Azure Stack only uses OpenID Connect protocol. So that's something you need to be aware of in your application design and support. Also, we talk about ID tokens that has information about the user, and session tokens But again, for more information and for more in-depth, check out aka.ms/azure/protocols if you really want to read more details about the protocols. This diagram here is to summarize the pieces of the puzzle that we've just described. The DT1 directory has users, service principals, and applications. There could be other directory tenants since Azure AD is a multi-tenanted system. A user could be invited to a second directory in which he is a guest in that directory tenant. That directory is a guest tenant. And applications can be single or multi-tenanted. If the application is multi-tenanted, there is a service principal of that application that is created in the second or guest directory tenant. This, in summary, is the Azure Active Directory application model. This will describe what happens when we use ADFS or Active Directory Federation services. The key points, as we briefly mentioned, ADFS with Azure Stack is single-tenanted. There is one directory, one forest. You have a user. You can create applications. The instance is the latest version of Active Directory Federation services, which is 2019. And we can create applications and application groups. And as we mentioned, the protocol for support is OpenID Connect. There is an application equivalent that creates an application in ADFS, and likewise a user account in Active Directory inside the stamp in Azure Stack. Let's take a look at the Azure identity model and how it applies to Azure Stack. This is also the Azure Stack identity model. So the portal and tools interact with Azure Resource Manager, or ARM. They authenticate the user and then issue a JWT token or a JSON web token. The client access to the ARM API layer is done through JWT tokens. Azure Resource Manager then makes calls to the individual resource providers. And this happens through a cert-based authentication mechanism, which is part of a trusted subsystem. The resource providers will call some business logic that the resource provider, or RP, governs. All of the default RPs use Kerberos, but when you add on resource providers, they can choose their method of authentication with the underlying data plane. This shows the portal authentication flow. When you go and log into the portal, this is what happens with the various redirects. The user goes to the portal unauthenticated. The user then gets redirected to an identity subsystem that it knows and trusts to get a token. The identity system presents a logon page to which the user enters their credentials. They get an authorization code and an ID token. This is the OpenID Connect flow. The user then returns to the portal with the assets to present to the portal. May I have access to resources now? The portal takes this and goes back to the identity system and says, hey, I have this authorization code that someone says you gave them. Can you please confirm? And then the identity system says, yes, I gave this, and issues an access token to present to ARM, or the Azure Resource Manager layer. Then a determination is made through ARM and RBAC what roles the user has and a list of what Azure resources they have access to. An analogy can be made in how you go to the bank and get a credit card. You go to the bank with their social security number, give them a bunch of money, and then they give you a credit card. You take the credit card and swipe it to buy some merchandise. The reader will then go back to the bank and say, hey, this card has been swiped. Do you have enough money? The bank says, yes, this is a valid transaction. They have money in the bank. Now you can give them the merchandise. So that's a simple example of how this process works in the real world. Portal login with multiple Azure AD tenants. So why is this section relevant? This is how the Azure portal abstracts all of this from you. We'll talk about this in the context of the Azure portal, but the same context applies to accessing the Azure Stack portal. When you go to the portal, portal.azure.com, the portal says, I don't know who you are. Go to Active Directory to authenticate yourself. It sends that to a common endpoint in Azure Active Directory. The user enters credentials, and then Azure Active Directory says, I see the directory tenant name, so I'll redirect them back to that endpoint. Then they will be authenticated and get a token, and then they return to the portal. The user could be a member of multiple tenants. So in this scenario we're looking at with a particular tenant identifier. When Joe logs in, he gets logged into his home tenant, not the other directory tenants. If Joe wants to access another directory, he can go to the picker at the top right, or Joe can explicitly log into the directory to the desired tenant by appending that directory tenant name at the end. For example, portal.azure.com/fabricam.onmicrosoft.com. The bottom line, you always log into the portal or API in the context of a particular directory. If you're a guest to a directory, you can specify that directory when you log in as we described. Now let's talk about some basic Azure Stack identity fundamentals. There's two possible options for identity provider. These decisions are made during the deployment. You have to determine if you're going to use Azure Active Directory or ADFS. As we mentioned, the OpenID Connect protocol is consistent with what the Azure portal uses today, and this is the protocol selected and used by Azure Stack. Because of this consistency with Azure, you can use the same set of tools, for example, PowerShell, CLI, REST API, etc. Since there are parallels now across Azure Active Directory and ADFS for authentication, these protocols and tokens work in either scenario very well. You can also use the Azure Active Directory authentication libraries to authenticate with Azure Active Directory, as well as ADFS against Azure or Azure Stack. In this chart, I highlighted some of the differences that stand out in the capabilities and limitations of using Azure Active Directory versus ADFS or Active Directory Federation services. In most of them, they're all similar. We'll start with the connected to the internet. So in ADFS, particularly if you're doing a disconnected scenario, you would do ADFS, but you optionally can connect to the internet. The main things that are different are what ADFS cannot do. And first of all, we see in the red no, support for multi-tenancy is not supported. Create service principals through the Azure portal. That does not happen because that would have to happen through ADFS in the stamp. Create service principals with secrets or keys. You can't do that with ADFS. And applications that use the graph service. But everything else are commonalities between those two identity systems. This is the configuration we've had since pretty early on in Azure Stack. On the left side is Azure Stack, and the right side we're looking at Azure Active Directory. You've been able to configure Azure Stack to one Azure AD tenant. In this scenario, you have admin users and tenant users all authenticating against this one tenant. Likewise, the applications would also be registered against Azure AD, which would have corresponding service principals. This is what the same scenario would look like, but in a multi-tenanted scenario. Azure Stack as an application can be connected to allow users from different directories to sign in and use it. This is a common scenario with CSPs or cloud solution providers where they're providing services to other organizations outside of themselves. This has all been architected in a way that the admin portal and Azure Resource Provider are tied to one tenant as an example. This creates isolation of our administrative users from the public portals. When a user from different tenants log in, they will be redirected through their own ADFS to authenticate against their on-premises Active Directory. A token is obtained and then will be sent back to the portal to allow access based on what role-based access control or RBAC will allow them to do. How identities get into Azure Active Directory is not a concern of Azure Stack. Azure Stack only has a contract with Azure Active Directory and likewise with ADFS in that scenario. Therefore, however an Azure AD contracts with on-premises identity doesn't matter. They could be cloud-only created accounts or synchronized accounts. The admin portal and the admin ARM are single-tenanted. In other words, tied to the hoster's directory. The public user portal, ARM, and resource providers are multi-tenanted. In other words, they can serve user service principals from different directory tenants in the case of the CSPs or shared hosting. The on-premises AD, Active Directory, can be synchronized with an Azure AD tenant in the same way that we can do with all the options if we have an Azure environment. Some customers have indicated they do not have Azure Active Directory yet, or they're in a totally disconnected state where they don't have access to the internet. So all their identities are on premises. Or they may be building their directories in a mine or in ships around the world, or a common scenario we'll see is in secured government locations that are totally disconnected. So without internet connectivity, how do I authenticate? As we said, when you deploy Azure Stack with this topology, communications will happen through the Azure or the Active Directory graph, and users and groups will be created in the Azure Stack stamp Active Directory, which were built into that subsystem of the fabric. But when you go to production, customers may want to integrate their existing on-premises directory. ADFS to ADFS federation establishes the trust for authentication redirection to the customer's Active Directory. This model is similar to what Azure does. Applications are coming from the Azure Stack, and users are coming from the customer location. Applications in Azure Stack are coming from the stamp Active Directory, but the users are coming from Active Directory, their own. To function, the AD graph requires an account in the customer Active Directory so it can do RBAC and people picker experiences. The Active Directory graph service itself is actually running on Azure Stack. This is a REST-based service, but only uses the necessary APIs to support Azure Stack. The point is that the AD graph is not a general all-purpose AD graph, but it was specifically designed and built for Azure Stack. It can query the directory for service principals and has the ability to query the customer's Active Directory for users, groups, enumeration, etc., and RBAC. It communicates through secure LDAP for role-based access control or RBAC scenarios. Let's just give a brief little review and summary about RBAC, if you're not familiar with that, but some key points that are important to highlight. So role-based access control in Azure Stack works very similarly in Azure Stack. The main difference of something we don't have in Azure Stack are the various and numerous built-in roles, but the primary roles of owner, contributor, and reader do exist. And if you need a custom role, you can create custom roles to fit it to whatever your particular needs are. We can assign these to users, groups, or service principals. Again, the built-in roles don't exist as we do in Azure, but you can make custom roles in the same way and then select those from the portal. So when we set up and determine role-based access control, it can be actually in two different worlds. So we can set this up for the administration portal if we wanted to delegate out for Azure Stack operators. That is one possibility. The second possibility would be within a subscription that users are using in the user or /tenant space, you could also have role-based access control set up. So as an example, if I'm a provider and I give access to Mark at markgrimes.com and he creates a subscription, he will actually own that. I can see that subscription inside of Azure Stack, and we'll talk about that in other modules or workshops. But unless Mark grants me, the administrator, access to that as the owner, I will not be able to see inside that, even though I'm the Azure Stack operator. So if I want total control of that, for example, if I need to monitor or set up things, one other option may be that for the role-based access control in the user or tenant space, I, as the Azure Stack operator, create the subscription. I am the owner. I set up everything, and then I can grant access to the other people, and then they can remove me. So I can make someone else an owner. They can remove me, but that allows me to get inside and set things up. So that's a consideration you may want to think of. So in custom roles, there are different things we'll show you in a couple slides about how we can customize these. The roles are composed of actions, not actions, and scopes. So let's talk about kind of the scopes part here. So we can apply role-based access control at 3 different scope levels, or this would be the subscription, the entire subscription, for the individual resource groups, which are just containers within the top level container, which is called the subscription, or within resources within those resource groups. And at any of those 3 scopes, as we mentioned, you can either be a contributor, which is pretty much everything. You can delete, create, all rights. Most people and most roles probably don't need much more than the owners have those full rights. The contributors is what most people are going to need to do to do their work. Readers, you may wonder why we want people to just read. Well, we want people, maybe high-level architects, to see what's going on, but we don't want them to accidentally click and accidentally delete something. So we can make readers for that. Also, monitoring tools would require reader access as well. Owners, again, with that top level rights, we want to keep that as minimum as possible and only have a few for backup purposes. But most people will say that they need to be contributors. So when someone in a subscription, whether it's Azure Stack or in Azure, says, I need to be an owner, I always have the discussion, is that inside the box or outside the box? Because once they log into that server, like if it's a server that has an app and they log in to that server in the subscription, that has nothing to do with role-based access control. Role-based access control has to do with the Azure or Azure Stack resources that we see in the portal and the resource groups and the subscriptions. And a lot of people do not necessarily need those rights. Ideally, in my perfect world, we'll talk about this later on in another module, we want the deployment of all these resources to be done with a high-level account that deploys everything automatically, and then people simply can access by remotely logging in and or contributor if that's even needed. So breaking down the custom RBAC roles, there are 2 key concepts. Role definitions, which defines the set of permissions, in other words, what you can do. And these role definitions can be reused in multiple assignments or different scope levels. And then the assignments associate role definitions with an identity, for example, the user group or service principal, and then at a particular scope, again, the whole subscription, the resource group, or the individual Azure resource. If you only do one, it's going to be inherited. For example, if you put an assignment at the subscription, it will apply to all resources within that. So again, just to highlight, built-in roles don't exist, but this just shows in this slide an example of what, well, let's clarify. The built-in roles as in Azure don't exist. The built-in roles that we have in Azure Stack are owner, contributor, and reader. So an owner has a star value to it, which means it can do anything and everything. The contributor, as you see here, it has all the actions, everything that can be done at that particular scope that you apply to, but it has not actions of authorization to write. So in other words, if I'm a contributor to a resource group, I cannot grant someone access to be able to do something. If I'm also, the other thing we cannot do, pause. The built-in role contributor also cannot delete authorizations. So if an owner granted access to a user group or service principal and someone else, Mark, had the contributor rights, he could not take those rights away from someone else. And as we see, the reader is just */read, so any and all abilities to just read, again, for architectural review and or monitoring type tools. Keeping in mind the concept of least privilege, we want to do just like in Azure and really only give people what they need to do. So best practices, we can do a lot of this as far as setting it up in the portal or the ARM API. And of course, with the ARM API, we can set this up in our DevOps pipeline as we deploy things, particularly in the user space subscriptions. so that users are granted only that which they need and no more. Custom roles configuration. So there is a get-azure RM role definition command to output the base role in JSON format if you want to look at those. And then you can open up a common editor. And then there's also a new-azure RM role definition command that specifies the JSON role definition file. And then finally, you can assign the role to the user. And this takes a look at the example of the JSON file. So in this case, we have a role called AZS test for Azure Stack. Is a custom true? The description is for Azure Stack registration, and you see the actions are the provider for registration, the resource provider for registration in Azure Stack, and a /star. So all capabilities are enabled for that. There's nothing in not actions, data actions, not data, but the assignable scopes. In this case, it's not going down to the resource or the resource group, but this applies at the subscription level. And you can set these and assign these and then reuse them or change them and modify them. That's the good thing about doing that. Final notes about multi-tenancy. We've covered this a little bit, but again, Azure Stack can support users from multiple Azure Active Directory environments. One tenant subscription equals one Azure Active Directory or an instance of Azure Active Directory. And when we're setting this up, it will often require coordination between the Azure Stack operator and the admin of the tenant in Azure Active Directory. In most large corporations, this will be someone who has the global administrator right in Azure Active Directory. So you'll need to work with that cloud team unless you happen to be one and the same and have full control over all those. So from an RBAC perspective, this is kind of a best practice. One particular method, and particularly in Azure Stack and the simpler non-CSP but enterprise type scenario where we have a single Azure Active Directory, and then we can have one or more subscriptions either by department or production and non-production, maybe sandbox. And then within those subscriptions, we have resource groups, and then within those resource groups, deploy things out. Quick note on the resource groups, we didn't talk about that much, but question comes up, why do I make one or more? So when you think about resource groups, there's two things to keep in mind. First of all, resource groups, as we said with RBAC, we can use that as a method to delegate administration. So if I want to have a container of things in Azure or Azure Stack and grant access, I could make Mark a network administrator to control all the network things in the network resource group. Not saying that's always the best design, but just as an example of something I could do. The other thing is, and probably the better answer, is thinking of it as a deployment methodology. So anything and everything you have to deploy in Azure or Azure Stack has to go into a resource group, and an Azure or Azure Stack resource ID cannot live in more than one resource group. So when you think about applications, you look at how you group them together and how you deploy them, particularly in dev test environments, because if you want to quickly and easily remove something, I've seen organizations where they'll create a resource group for Mark because he's testing something out and Mark has contributor rights to that. He deploys everything and anything he needs in that resource group. And when he's done developing and testing, he can save that code for reuse into the production subscription and redeploy it. And then to get rid of all the objects nice and cleanly, just simply to delete that resource group. Okay. So that's one scenario that we can look at here. And then in the CSP or cloud solution provider environment, this is where you're going to have multiple subscriptions that are linked to multiple Azure Active Directory tenants, but always from one subscription paired to one Azure Active Directory. So it's important to emphasize the fact that the subscription is linked to one Azure ID, can have resources only from that Azure Active Directory within Azure Stack. So again, just a summary here. So if we enable multi-tenancy, we configure Azure Stack Directory to allow sign-ins from the Fabrican tenant. And there's documentation that walks through that process. It's pretty straightforward to enable that. And then likewise, to configure the guest directory, you have to register the Azure Stack with the guest directory. And there's the link in the docs for enabling that process as well. So very, very important on this final note about multi-tenancy. If the Azure Stack administrator or operator installs new services or updates in the future, there may be scenarios, it doesn't always happen, but there may be scenarios where the customer will need to rerun the multi-tenancy enabling script again. So before you do that, you always want to do the test-Azure Stack command that we mentioned in the support module or workshop, and make sure everything's happy. Then, and again, you wouldn't necessarily do this unless instructed to do so, and the installation or update to that resource provider would indicate at that time that that is needed. There you have it, folks. That's the module on Azure Stack Identity. Thank you, and have a great day.